Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future today. Imagine this moment. It's late at night. Your laptop fan is spinning like it's about to lift off. A training job has been running for days. And somewhere in the back of your mind, a quiet question keeps coming back. Why does intelligence have to be so heavy? That question is exactly where the story begins. The paper I'm about to tell you about is called Ministral 3 Efficient Dense Language Models via Cascade Distillation. And this is not a story about making models bigger, it's a story about making them wiser. Let's rewind. For years, the AI world has chased scale, more parameters, more tokens, more compute, trillions of tokens burned just to teach a model how to speak, reason, and see. Models like Llama and Quen became giants, impressive but expensive. And here's the problem. Most real world systems don't live in giant data centers. They live on edge devices, on limited GPUs, inside products that need speed, not bragging rights. So the authors of this paper asked a bold question. What if we don't start from scratch? What if we start with something strong and carefully shape it into something smaller? Enter the hero of our story, a powerful parent model called Mistral Small 3.1, 24 billion parameters, well trained, dot capable. Instead of throwing it away and rebuilding everything from zero, they decided to teach it how to have children. This is where Ministral 3 is born, not one model, a family, three sizes, 14 billion, 8 billion, 3 billion parameters, and for each size, three personalities, a base model for raw capability, an instruction model for helpful dialogue, and a reasoning model for deep thinking, nine models in total, all open weight, all designed for efficiency. But how do you turn one big model into many smaller ones without losing what made it smart? This is where the story gets interesting. The authors introduce a technique called cascade distillation. Think of it like a relay race. The parent model runs the first lap, then hands the baton to a slightly smaller model, which hands it to an even smaller one. But at each handoff, knowledge is carefully preserved. The process has three repeating steps. First, pruning. Layers that matter less are removed. Hidden dimensions are compressed using PCA. Feed-forward networks are trimmed based on real activation importance, nothing random, nothing careless. Every cut is informed by how the model actually behaves. Second, distill. The smaller model doesn't just predict the next token, it learns to imitate the parent's thoughts through logic distillation, first with short context, then with long context, all the way up to 256,000 tokens. The teacher speaks, the student listens. Third, repeat. 14 billion becomes 8, 8 becomes 3. And here's the elegant part. This all happens in one continuous training run. No restarting, no reusing data, no massive retraining budgets, just shrinking intelligence step by step. Now you might expect performance to collapse, but it doesn't. In benchmark after benchmark, the Ministral 3 models punch above their weight. The 14B model rivals much larger systems. The 8B model often beats competitors that are bigger. Even the 3B model holds strong in math code and reasoning. This isn't just compression, it's efficient inheritance. But the story doesn't end with pre training because knowing language and using language are very different things. So the authors move to post training. For instruction following, they use a two-stage process. First, supervised fine tuning, clean data, high quality instructions. Then something clever, online direct preference optimization. Instead of static human labeled preferences, the model samples its own answers. A reward model compares them. And bad behaviors like infinite loops are punished immediately. The model learns in real time what good answers feel like. Now let's talk about the reasoning models. These are trained differently. They start with chain of thought data, then move into reinforcement learning with GRPO. First focusing on STEM problems, then expanding to general reasoning and dialogue. And because reasoning takes time, the generation length is increased dramatically, up to 80,000 tokens. The model is finally allowed to finish thinking. But there's a lesson here. More reasoning isn't always better. When the authors pushed too much long chain of thought data, the model became verbose, over reflective, lost in its own thoughts. A reminder that intelligence isn't just about depth, it's about clarity. One of the most surprising discoveries in the paper comes next. A stronger teacher is not always a better teacher. During pre training, distilling from a massive model actually hurt performance. Mistral Small 3.1, the more balanced teacher, worked better. But during post training, stronger teachers helped again. Same technique, different stage, different outcome. This nuance is rare and incredibly valuable. So, what is Ministral 3 really telling us? It's not just a set of models, it's a philosophy that intelligence doesn't need to grow endlessly outward. It can be refined, compressed, passed down from one strong ancestor to many capable descendants. And maybe this is the future of AI. Not a single giant brain ruling the cloud, but families of efficient models living closer to where we actually need them on devices, in products, in the real world. And the next question becomes, if we can distill intelligence this well, what else can we pass down? If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.